Hello, everybody. Thanks for tuning in. Thanks for coming. If you're on YouTube watching the live stream, thanks for coming. Um, yeah, if there's any issues with like seeing my screen or hearing me or anything like that, please let me know. I'm really bad with microphones generally. But yeah, today we're going to be talking about, in general, Layer Zero, Stargate, and the products that we offer and how we make the on-chain space a little bit better. But the general goal I want and the general message I want to convey in today's workshop is building omni-chain composers. If this line already makes you wonder what that is, stick till the end. Yeah, I'm John. I'm a developer relations engineer at Layer Zero Labs. I'm 0x John on Twitter. If you've never seen me at Layer Zero before, it's because I just joined. So yeah, hopefully you'll enjoy this workshop. So yeah, quickly about the agenda today. I'll just talk about how Layer Zero works, the 101s of cross-chain messaging. I'll talk about how Stargate works, this idea of composability, and as well as show you a simple example of a Aave composer that I built the other day. Also, there's a repo for it in the Discord. So if you see the partner dash layer zero chat on ETHGlobal Discord, you can go there and there's a bunch of links in there that you can find useful. So to start off, Layer Zero as a global ledger or bridge infrastructure. If there's anything I want you to understand and to take away from this workshop are basically these three things. Layer Zero as a bridge infrastructure is built upon three core principles. The first principle is permissionlessness, right? Secondly, it's censorship resistant. And thirdly, it's immutable. What is Layer Zero? So Layer Zero is essentially just a set of smart contracts that we deploy to every chain that we support, that your app can interact with to send cross-chain messages. So at the core of it all, you're just sending a message from chain A to chain B in a secure way. And you can build many applications on top of this core principle of message sending, and I'll go into it a little bit deeper. So just again, to zoom in, I'm gonna go through a simple like workflow of a message being sent from chain A to chain B. A little prerequisite to any sending, any message sending like that will happen. You need to configure your own security stack, right? So when a message flows from chain A to chain B, there's some middleman that needs to kind of verify that this message has not been tampered with. So we call this the security stack, or DVNs. DVNs stands for Decentralized Verifiable Networks. And the second thing you need to set up is the executor. So the executor on the destination chain is the one actually delivering and calling the function calls on the destination to deliver your message. So if we start from the very, very beginning, you have an app. This is your app, and you can send arbitrary data from your app on chain A to your app on chain B. And this data could be arbitrary messages or assets, tokens, or even assets plus data, which is very useful for the concept of composing that we're going to go into a little bit deeper. But essentially, your app interacts with the endpoint here, right, which is the interface for interacting and sending cross-chain messages. After that, the message is emitted from chain A, and the security stack that we've configured, which consists of DVNs that you pick yourself. So it could be Google Cloud, it could be Layer Zero. If you want some middle chain like Axelar and Wormhole, that also is supported. We currently have like 54, I believe it's 54 DVNs that's supported. So you, as the app developer, can configure the amount of DVNs that will verify the network, which ones will be required, and which one are optional. After that, after each DVN independently verifies that the message or the payload has not been tampered with, the message will be sent to this contract called the message library on the destination chain. And the executor that I mentioned previously will be the one calling the function to deliver that message through the endpoint to your app. So going through this like send flow from the chain A, from chain A, then verifying this message and delivering it to chain B. One important note about modular security stack that we kind of call is that historically, as a developer, when you're building an app that needs to interact with another app on another chain, you're kind of left with two choices. You either go for really high security, which consequently means that the cost of each independent transaction is very high, or you choose something with lower security, which means that the cost will be lower. So what Layer 0 allows you with modular security is that you can pick and choose your own security to your own taste, and essentially pick any point on the graph, which is like whether you want it to be secure or if you want it to be super secure, obviously your user would need to spend a little bit more on fees. And then another neat feature about this is, as our industry evolves, we oftentimes get new validation techniques, so new techniques to verify that our message hasn't been tampered with. In our case, you as the developer can simply modify the configuration to switch it to that new validation techniques. So for example, polyhedra for ZK proofs, or anything like that. I think so this was basically the basics of what Layer 0 is. It allows you to send messages. But to kind of build on top of that, one of the core primitives and the main use cases of messaging is token transfers, right? Sending assets from chain A to chain B, this is the core of any bridging, right? So if we look at the example of doing it for a single chain, so for example, you're sending from a user A to a user B on one chain through the ERC20 contract, all it is like there's a central database or a mapping that you're updating. So you're basically decreasing the balance of user A and increasing the balance of user B, right? So that's simple enough. When you start to plug in like multiple chains and have something called omni-chain transfers, it suddenly becomes a little bit harder. Now you have to kind of bookkeep and keep track of all these balances across multiple chains. And yeah, there's many more function calls and state changes on both chains. So the way we do it is also using messaging, right? So imagine you have these like OFTs. So OFTs are omni-chain fungible tokens, which essentially are extensions of ERC20 that allow your token to have omni-chain functionality. So on chain A, you can imagine a burn function that is being called on your underlying ERC20. A message is sent across chain to chain B, and a mint function is called to kind of create those tokens again on chain B. And essentially, this is the basis of omni-chain transfers. But for you as a developer, in more practical terms, we've built these standards, like I just mentioned, the OFT standard, for you to simply inherit from and use in your contracts if you want to kind of use this technology. So there's a couple of standards that I want to go through quite quickly. So first is the standard OFT contract, right? This one would allow you, and you would generally use this if you're creating a token from scratch. So if you're issuing tokens from scratch, kind of like Layer 0 with ZRO, Stargate with STG, or Shrapnel with Shrap, you can use the OFT standard and kind of deploy those OFTs on different chains and have them essentially interact with each other on multiple chains. But if you're using an existing token, right, for example, USDC or something like that, you can deploy something called an OFT adapter. So the OFT adapter essentially is a wrapper or an adapter around the existing token that would essentially lock on chain A and unlock on the other chain. And again, those two chains and those two apps talk to each other via the Layer 0 messaging protocol. So that is when you want to, something like, it's called a lockbox if you want to unlock and lock on the other side. There's also a mint and burn adapter. These is for the cases where you have an existing token, and that existing token gives you access to the mint and burn functions, right? And when you have access to the mint and burn functions, you can essentially go and burn on one chain and mint on the other chain. So a few partners that have used mint and burn adapter are Ondo for their USDY, PayPal for their PYUSD, and BitGo for WBTC. Also, a few examples of adapters, the standard lockbox adapters being used. You might have heard of USDT 0 issued by Tether. Ethena issued USDE and SUSDE through OFT adapter as well as EtherFi. Some of their kind of wrapped Ethereum tokens are also part of the OFT adapter standard. So what is Stargate, and why I started kind of explaining Layer 0 and OFT? Well, Stargate essentially plays a dual role in the Layer 0 ecosystem. So the first role is that it's a de facto front end, the primary front end for all OFTs in the Layer 0 ecosystem. That's the first thing. But secondly, what might interest you as the developer is that Stargate is a liquidity provision protocol. So essentially, they manage liquidity between multiple chains for a lot of these popular tokens that you use, like USDC, USDT, or WETH. And you can basically interact with Stargate contracts to send tokens from one chain to another. And Stargate uses layer 0 under the hood as well. So one thing to understand about Stargate before we dive a little bit deeper are these concepts of native chains or native pools and Hydra. So essentially, native chains are chains where a lot of these tokens like USDT and USDC are natively deployed. So the token issuers like Tether and Circle, they don't deploy on every chain, obviously. Most native chains are the popular ones that you know, like Base and Arbitrum. So that's where Stargate have the Stargate pool contract, right? There's also the Hydra chains. So Hydra chains are emerging chains, kind of like Monad or Plasma or Scroll, where the token issuers like Circle or Tether didn't deploy and don't have deep liquidity yet, but they still want to tap into this token and have their dApps integrated. So that's what we call Hydra chains. So for native chains, again, there's a contract called Stargate Pool, right? And essentially what it does, it locks on chain A and then sends a 0/0 message through the endpoints and then unlocks on the other side. Quite simple. It also keeps this like liquidity balance between using a credit allocation system, which is kind of interesting. And then the contract that is called the Stargate OFT is actually deployed on Hydra chains. So for example, you want to send USDC or USDT from Ethereum to any Hydra chain like Plasma, you would actually go through this flow. You would call the Stargate pools contract on Ethereum, and then a message would be sent to Plasma, for example, and the Stargate OFT will pick up that message and mint a one-to-one backed representation on Plasma, essentially allowing these newer chains to have like a one-to-one backed liquidity pool on the native chain, which is kind of cool. One thing really important to note about both the Stargate OFT and the Stargate pool contracts is that all of them are actually OFTs. So all of them inherit and implement the IOFT interface, which means if you know how to use and interact with regular OFTs, you inherently know how to use the Stargate OFT contract and the Stargate pool to send assets cross-chain. This leads us to a really neat kind of concept called composability. So think about this in terms of a hacker, a developer, right? You're going to be building something for this hackathon that has custom logic. Likely it will have some exciting functionality or something like that, right? Just sending tokens from chain A to chain B, well, in one case it's pretty cool, but on another hand, it's kind of not that exciting. So what makes this a little bit more cool is this idea of composability. Composability, essentially what it allows you as a developer to do is to chain actions on the destination chain. So essentially asking the question, what would I do after my tokens are transferred on the destination chain? For example, you would want to supply it to Aave immediately. For the user, that would be just one click, right, from the source chain. You want to supply it to Aave, you want to swap it through Uniswap, or you want to do some other complex things. This is what composability allows for you. So you might think, well, composability is kind of easy, right? You just essentially chain up a bunch of function calls inside another function. So for example, we have this function called lzReceive on the destination chain, which delivers the actual message to the app on the destination chain. What you can essentially do, to be honest, right, is just call contract A, function A on there, and then contract B and contract C. But the problem with this is since blockchains are atomic, and all transactions on blockchains are atomic, if even one call fails or reverts, the whole contract call will revert. So obviously that is not ideal. We solve this by introducing something called horizontal composability. So remember I told you about this executor that essentially is the one calling the contract and making the transaction on the destination chain. So this same executor can be used for the purposes of calling that sequence of transactions and sequence of custom logic that you have on the destination chain. For example, supply it to Aave or swap on Uniswap. So again, you could essentially think of these as like checkpoints that the executor would do on the destination chain. First, it would receive the tokens and send it to whoever needs to get it. And then secondly, it would just call another contract. For example, Uniswap or Aave. One really cool example of composers is something called an omni-chain vault. So we built this standard, which essentially is a ERC 4626. If you guys don't know what that is, essentially it's a standard on Ethereum that would allow you to build a vault that can accept deposits and mints a shared token, kind of saying that, okay, you as the user or your user have deposited to this vault and received this amount of ratio of the vault back to the user. So when doing it on a single chain, obviously things make sense. But what if you want to accept deposits from multiple chains and also receive those tokens, the shared tokens, on multiple chains? So that's when omni-chain vaults come in, right? So the standard flow for any omni-chain vault is basically the user on, for example, Arbitrum sends a call to send, for example, USDC from Arbitrum to any hub chain like Base, right? Under the hood, there's obviously the layer 0 message. The tokens will be, you'll receive the tokens on the destination chain, and then the composer would actually call with those USDC tokens that you sent, would call the ERC 4626 vault and deposit those tokens in there. And then also, since those shares that are minted are ERC20 tokens, they can be wrapped as an OFT adapter. And so those instantly become omni-chain as well, and you can transfer it to any other spoke chain, or what we call, spoke chains that you can define and configure yourself. You could essentially send those share tokens to any other spoke chain. Some things to note about just composing in general is the fact that, again, the executor is the one actually calling the functions. So it is really important to set enough gas, because, again, from a user standpoint, all they did was sign one transaction and send on the source chain. Everything else is working under the hood. So the important thing that you need to note, right, is to quote the fees from these workers and the executor beforehand, so that you can essentially be sure that the transaction won't revert because of lack of gas. So with the options builder, or what we call like basically how to set gas, right? You can essentially just call LZ receive option and set the gas limit for the executor calling LZ receive. The same thing goes for LZ compose options, which essentially sets the gas limit for when the executor calls LZ compose. And yeah, I wanted to show you a quick demo of the Aave composer. So essentially what this demo is going to show you is a user calling send on any arbitrary OFT contract and sending a message to chain B, in this case will be base mainnet, receiving the tokens and queuing up a compose message, essentially saying that I want to deposit something into a lending protocol. In this case, we are going to use Aave v3. And the user on the destination chain will receive the receipt token saying, we have essentially deposited into Aave successfully. So let's go to the repo. So if you're, again, if you're in the ETHGlobal Discord, you can just go to partner layer 0 channel, and you can see the link to this repo over there. So let's go through the README, I guess, real quick. Yeah, you can just clone the repo, CD into it, and important thing you need is the private key. So in this env.example, we have the private key of the deployer who's actually going to be deploying the token standards. After that, you have to set your chains, right? So there's a hardhat config.ts file where you set the chains that you're going to be working with. So in this case, it's going to be the Arbitrum mainnet, where the user is going to be sending USDC, and base mainnet, where the user is going to receive USDC and instantly deposit into an Aave contract on base. After we've done that, and yes, I went ahead and already configured both Arbitrum mainnet and base mainnet, you can install and compile. So the first thing you need to do is deploy the composer contract, right? And if you wonder how the composer contract looks, let me just, So essentially, we have to import a couple of interfaces like iLayer0 composer, which essentially defines the LZ compose function that will be called by the executor, as well as the Aave v3 composer, which essentially is just some errors and some events that I made for mainly for code organizing. right? The main thing in the constructor that we are doing is, again, the constructor receives the Aave pool contract, right? This is the contract on Aave that receives deposits, as well as the OFT contract that we are going to be using. So in this case, we're going to use Stargate. As I said, you could either deploy your own custom OFTs for this, or you could use Stargate, because Stargate, at the end of the day, are also interfaced in the same way as OFTs. Yeah, so essentially in the constructor, we set all of these variables and also give a one-time approval for the Aave contract to spend tokens on our behalf, on the behalf of the composer in this case. And the most important contract call here, or the function here, is called LZ compose. So I'm just going to skip through this, but yeah, what's important to note is this OFT compose message codec, which is essentially the standard that we use, or the library that we use to encode data on the source chain, and also consequently decode data on the destination chain, right? So we are going to be passing the amount of tokens to supply and decoding that from the message itself. We're also going to be decoding the address too. So essentially, the Aave.supply function, what it does is it takes in a couple of values, the amounts, how much you want to supply, which token you're supplying. In our case, it's USDC. And this third parameter is the address of the user who wants to receive the receipt token. So this is what we kind of encode into our initial send from the source chain. Obviously, if anything goes wrong, we call the refund function. The refund function, again, sends a layer 0 message back. So you can even refund back to the source chain, even though the tokens are on the destination chain already. So this should be pretty straightforward, wrapped in try and catch, so that, yeah, we know when something goes bad. But yeah, the main thing here is we need to deploy the composer contract on base mainnet, right? Again, as I said, we need some values to pass into the constructor. So we need the Aave v3 pool address. Where you can grab that is on the Aave docs, right? You can go here and grab the addresses. The target chain is base v3 mainnet, so let's just grab this contract address, right? And the second thing is Stargate pool address. The Stargate pool address you can also find under, I left this in Discord also under links, but there's this page on our docs called OFT ecosystem and Stargate assets. You can essentially just filter for all the tokens, the OFT tokens that are issued by Stargate, if the Wi-Fi allows me. Yes, thank you. Give it a minute, yes. And then look for USDC, or I guess look for base. That is so slow. A base. All right. So you can see the contract here. So we see the issuer is Stargate, the type is Stargate pool, and the contract address is this OFT field right here. Right, and then you just attach it here. Right. Yeah. So the call the task itself is pnpm hard hat lz deploy with the tags as the name of the contract. So what this would allow you is give you a CLI to deploy to your defined hard hat chains. So in this case, we'll deploy the composer to base mainnet. Skip 3Ds, and yeah, you will see that our contract has been deployed to this address. You could also find the contract address under deployments and Aave v3 composer JSON. So here's the address. So let's also test the send functionality. So again, what we're going to be doing is sending USDC from Arbitrum to base, and then immediately supplying it into Aave. Right, so in the README that I provided, there are essentially a couple of things that we need to pass into here, but it's fine. Right, so first of all is the network from which we are calling, so essentially Arbitrum mainnet. The amount in local decimals, yeah, importantly, it's in local decimals. So the last time I checked, USDC has 6 decimals on base and on Arbitrum. So we're just going to be sending 1 USDC in this case. So 1 with 6 zeros. You want to attach your composer address as well. Again, you can find it over here under deployments, right? You also want the destination endpoint ID. So where do you find that? Essentially, on that same page where I showed you where you can find the Stargate contracts, you can also see the endpoint ID. So the endpoint ID is essentially the ID of the contract that we as Layer 0 deployed on the destination chain. Sorry, yeah. So it's right here, endpoint ID. And importantly, we need the contract for the Stargate pool or any OFT that we are quoting from on the source chain. So in this case, it's not Base, it's Arbitrum. Obviously, you can automate this process, but yeah, I figured I would want to show it to you guys since we are doing this from scratch. So this should be enough, right? So the task name is Aave Supply, and it's just PNPM hard hat Aave Supply. So first thing it's going to do is going to prepare the Stargate supply compose, right? It's going to check for any current allowances, and then it's going to submit a transaction. Okay, so we get this transaction hash where you can go to LZ scan and check the status of this transaction. Again, hopefully the network will allow us to view this. Okay, so what are we waiting for? We are waiting for the required DVNs or verifiers to verify that this message has not been tampered with, right? So in this case, the verifiers are Nethermind and the Stargate DVN itself. We commit the message, and the executor is going to call LZ receive first. We see that succeeded, and it's going to call the LZ compose next. So again, we see that this is succeeded as well. The token transferred, you can see that it was 1 USDC, and without even going to Aave, we should see 1 AUSDC, which is essentially the receipt token that Aave sends back to the user when the supply was successful. Let's also double check whether this has worked or not. This is, yeah, the Aave interface. And as you can see, close to 1 USDC, obviously. But yeah, $1 worth of USDC has been supplied into Aave. That should be it for the workshop. If you have any questions, let me know.
This example, for example, if I want to withdraw. Sorry. So in this repo you have, for example, if we want to withdraw the funds, it's going to be cross-chain too, or it's going to be on base, even though I send it from Arbitrum. Is that
no.
logic
Yeah.
handled?
Yeah, you can definitely, it's not defined in the repo that I provided. But again, yeah, all Layer 0 is sending cross-chain messages. So you can essentially just use that same logic to withdraw the funds, or even call like other functions on other contracts. For example, call the swap router for Uniswap and swap the tokens immediately, or obviously like do whatever custom logic you guys as hackers that like you guys are building more exciting things obviously than just swapping and supplying. But yeah, whatever you feel like is needed, I think you can definitely come by our booth or ask the question on Discord. We can help you out here. But generally, yeah, this should be possible.
Perfect. Thank you.
Yeah.
Do you repeat how I get the composer hash?
Oh, the contract address.
Yeah.
Yeah. So the way we have the repo structured is there is this deployments directory, right? After calling pnpm hardhat, after calling this command pnpm hardhat lz deploy, essentially what is going to be created is this deployments folder, right? It's going to have the chain inside of it. There's going to be a directory for the chain where you deployed the contract, and you're going to have the name of the contract .json, which will have the contract address defined in there. Yeah. All right. I think that is it. Thank you so much.